Very good morning to all. Myself, Dr.P. Gopinath, Assistant Professor, Selection Grade, Department of ECE, KIT, Kalaignar Karunanidhi Institute of Technology, Coimbatore. Today we are going to discuss the topic, subject is transmission lines and waveguides. This first title is a general theory of transmission lines. So generally transmission lines, why we are using means, we are communicating, that is a electrical information we are going to convert one place to another place. So this is the transmission line diagram. It consists of two-port network connecting a generator circuit at the sending end to a load at the receiving end. So in this part, that is a sender side, we are going to connect, that is a input voltage and the resistors. Then information going to transmit particular transmission line. Then receiving end, we are going to connect load resistance. It's a load circuit we are going to connect it. Then common types of transmission lines. So different types of transmission lines we are going to performing on. The first one is a coaxial line. Second one is a two-wire line. Third one is a parallel plate line. Then fourth one is a microstrip line. Then fifth one is a waveguides. So these are the different medias we are going to communicating our information using these transmission lines. Some examples of transmission line. Transmission line in communication carry. That is the first one is the telephone signals. Then computer data in LAN, TV signals in cable TV network, telegraph signals, antenna to transmitter link. So these are the informations we are communicating one place to another place using transmission lines. The basic transmission line consists of, this is signal source is there, then terminal end. In between we are using transmission line. Then any complicated network with the terminal voltage and current indicated. So this is a simple circuit. We are going to connect, that is the input side. We perform, that is a voltage 1 V1. Then current flow is mentioned, that is I1. Then output side, that is a voltage source should be denoted V2 and current source should be denoted I2. A succession of n networks in cascade. This is the structure for cascade transmission line. Then generally complicated network can be reduced to T or pi network. So in this circuit we have to illustrate, that is a T circuit and pi network circuit. So here the shape should be mentioned, that is a Z1, Z2, Z3 should be connected in T shaped network. Then here ZA, ZB, ZC we have connected in pi type network. We are using two types of parameters, especially, that is the first one is a distributed parameters. So what are the distributed parameters means, that is a R should be denoted resistance per unit length, then L should be denoted inductance per unit length, G should be denoted conductance per unit length, C dash should be denoted capacitance per unit length. Then del Z should be denoted increment of length. So these are the distributed parameters we are using our transmission lines. Then primary and secondary constants of transmission lines consist of, first one is a characteristic impedance Z0. Then ratio of voltage to current V divided by I equal to Z. From transmission line model, Z naught equal to root of R plus J omega L divided by G plus J omega C. Now we analyze the performance of network performance. That is a performance, how to calculate means, that is a input current divided by output current. If the ratios of voltage to current at input and output of the network are equal, then that is I1 divided by I2, that is also equal to V1 divided by V2. So we are going to measure the performance of our information. Then propagation constant is the important source, that is a V1 divided by V2 equal to I1 divided by I2, that is equal to e power n. The magnitude ratio does not express the complete network performance. The phase angle between the currents being needed as well as. The use of exponential can be extended to include the phasor current ratio, that is I1 divided by I2 equal to e power gamma, where gamma is a complex number defined by all gamma equal to alpha plus j beta is nothing but I1 divided by I2 equal to e power gamma, that is equal to e power alpha plus j beta. Then I1 divided by I2 we have denoted a angle of beta. A should be denoted I1 divided by I2, that is nothing but e power alpha. Then beta equal to e power j beta. With Z0 termination, it is also true. That is a V1 divided by V2 equal to e power gamma. The term gamma has been given the name propagation constant. That is denoted alpha is nothing but attenuation constant. It determines the magnitude ratio between input and output quantities. It is the attenuation produced in passing the network. That means the units of attenuation is Napiers. Then beta should be denoted as a phase constant. It determines the phase angle between input and output quantities. If phase shift occurs, it indicates the propagation of signal through the network. The unit of phase shift is radians. So in this alpha and beta is the important parameter for analysis of transmission lines. Then we have referred the transmission lines textbooks for John D. Ryder. That is a networks, lines and fields, second edition. Then some reference books also mentioned here. That is electromagnetic waves and radiating systems. That is E.C. Jordan and K.G. Ballman. Then G.S.N. Raju for electromagnetic field theory and transmission lines. Pearson education. Generally, transmission line is a wired communication using different transmission media. That is a twisted pair coaxial. So these are the cables we are going to utilize. Then one place to another place we have to take electrical pulses. So these are the very basic fundamental of transmission lines. Thank you.